Hey, what's up, guys? This is Sean here again. Let's continue our LeetCode journey here. So this time I want to talk about this problem 1434, number of ways to wear different hats to each other. I think this is a great hard problem, you know. Okay, so let's take a look. So at the description here. So there are like n peoples and 40 types of hats labeled from 1 to 40, okay? And given a list of an integer of list where hats I means that a list of all the hats this ith person will basically can wear, okay? And it asks you to return the number of ways that n people wear different hats to each other. Okay, right. So basically, not all the combinations, but only the case that everyone is wearing the different hats. Okay. Since the answer may be too large, return it modular by this one. Okay. Mm, yeah. For some examples here, for example here, so the index in this hats represents the ID of the person. Okay. So in this case, which this one is like person one, person two, and person three. Sorry. Person zero, person one, and person two. So this one means for person zero, the person zero can wear hat number three and four. Okay, by the way, so the hat is one based from 1 to 40, and person one can wear like hats four and five. Person two can only wear five. And in this case, there's only one possible combinations, which is the person one wear three, right, person zero where three, person one where four, and person two where five, because we cannot have same two persons, two people like wearing the same hat. Okay. Okay, cool. I mean, this obviously this is kind of like a DP problem, you know. Why is that? Because, at the beginning, right? I mean, the total combinations is like what? It's n to the power of 40. Okay, right? So because for each persons, they're like it can like wear one of the from the 40 hats, but obviously we have a restriction here, right? Because we cannot not all, so all the persons have need to wear the different hats. Uh, that's why I mean this is like kind of like a DP problem, you know. For this kind of DP problem, and since two we have two sides, right? One side is n people, the other side is 40 types. No, actually, this one is very similar as the as last week's lead weekly contest problem. For that one, actually, it's we're trying to connect two sides of points with the other side. Okay, and then each side will have a like each connect has a cost, and they ask you to find return the minimum cost. Okay, but anyway, but for this problem, it's asking you to return all the possible ways. Okay. I mean, so the very first intuition will be what? Will be uh we're gonna basically assign the hats to each person. Okay. So a top-down DP will be most intuitive in this case. So I mean basically, so the first state for this problem is gonna be the numbers. Sorry, the person ID. Okay. So the person ID is the I, and then the second one is like a mask, you know. So this is like another problem that you need to use a mask to represent the state of the other side. Okay. In this case, I mean the first idea will be we use I represents the person, okay, and the ith person, and the mask represents the current state of the 40 hats. Okay, so I mean this thing, I mean the lo logically it is correct, but it will time out. So why is that? Because you know for the mask here, right? So we have each bit of the mask will have like two options, right? So in total, it depends on how many bits this mask has, right? In this case, it's going to be 40. So 2 to the power of 40, this will definitely TLE. So which means we cannot use a mask to represent the hats. Okay, then what can we do? If you guys scroll down here, see this one. The n is only like limited to 10. So which means we need to use the mask to represent the person. Okay, and basically we need to reverse these two things. So now I means the hat. So this is so now the DP I'm DP the first state means that H here, and the mask here, the mask means like at the H hats, okay, at the H hats, what's the state of the person that's wearing a hat, okay, because it at the most there are like 10 persons. That's why we just need 10 bit mask here, 4, 5 here, okay, and so this DP means that at the H hats here, right? And the state of of all the peoples basically, right? And we don't care. We don't care what I mean which hat that person is wearing because be, actually all we care is that if that person has a hat or not. Because the reason we don't uh let's see. Because we are since we are every time when we are finishing the current state, we'll be always increasing this height number by 1. So which means the current age can only be assigned to one of the persons. Okay, and basically it means that currently we're at height h here, right? So from 0 to height h minus 1. Okay, and will only be assigning those hats to the person that does not have a hat. So which means that at the current state here, right? At the current h hat here, so all the 0 to h minus 1 hats has already been assigned to a different person. Okay, so that we can guarantee that, right, at this moment. So there's no two person that's wearing the same hat because we are only assigning the hat to one person's at one time. Okay, cool. And so and every time, right, when we have like a hat here, right, we'll be updating the mask here, right? Basically, since we have this like a hats list here, given like a hat, we know what are the options, right? Basically, let's say there's a hat 3 here, and we based on this list here, we know that what are the persons, so who can wear this the hat 3 here. To do that, we just need to pre-process like this hats list first to basically because currently the hats is like it's like a person to hats. So now we need to create like a hats to person map here. Okay. Yeah, and yeah, basically that's the basic idea here. But one more thing to be noticed that here is that at hat H here, right? It's not we don't necessarily we're not necessarily have to use this hat because there are like 40 hats. There are 40 hats and we only have 10 persons. So which means at each of the hats here, we have two options. We can either choose to wear this hat or we don't have to wear this hat. Okay. That's the difference. I mean, comparing with the first approach, which the I is a person, in that approach, I mean, we don't have to worry about either wear or not wear because for the person, it has to have a hat, right? So we can just skip that part of logic. But since we are looping through the hat here, and then we have to split the logic into two parts. Okay, we either wear it or we don't wear it. Okay, cool. I think that's the intuition that I have here. So let's try to implement this thing here. Okay. Mm. All right. So like I said, and let's create uh, the hats to person map here. Okay. And we have a hat to person. How about that? I'm just using abbreviations here. So I'm gonna have like default dictionary list. Okay. Mm. So in this case, for the persons, okay, in the hats list, okay, the person actually this the ID the index is a person, okay, in enumerate hats, okay, and then we just do a hats to person. Oh, sorry. So for hat, okay, for hat in hats list, okay, so hats to person hat, right, dot append to person, okay. Basically, now after this for loop here, we have like a, a list for each hat, the persons that can wear this hat. Okay. Now DP, right? Now the DP parts. DP, the first one is a hat. Okay, I'll use the hat here, and the second one is the mask here. Okay. Mm, in the end, we simply return the DP uh, from 0 to 0. Yeah. Okay. So I mean for DP, I believe last time I used the like this LRU cache equals to none, right? Something like this. Probably this time I'm gonna save it because uh just to make sure the code is like the language agnostic, right? So that I will just use some regular ways of doing this DP here with memorization. Okay, so basically this is how I do the memorizations here, right? And if the H and mask in the memorizations, right? And then we simply return the memorizations uh, with H and mask. Okay, cool. So the answer is 0, and then we just return and then in the end, we simply set, okay, we set this thing here equals to answer, and then we simply return the answer in the end. Okay, now the part. Okay, so now the DP part. Okay, so like I said, since we are looping through the first one is a hat, right? So we have two options here, right? So the two options is the first one is we don't wear the current hat. So which means the answer will be what? Will be equals to uh, the dp of h plus one dot mask. Okay, it means that okay, we don't wear the current hat, which means the mask will not change. So the mask will only be changed when we decide to wear the current hat. Okay, so that's when we need the second scenario here. So the second scenario is that basically uh, if the hat is in H2 hat, okay. I'm just doing like this loop simple check here. I mean, we only do this if the current hat is in the map here. Otherwise, we can simply skip this part because no one will wear it, right? So if someone can wear it and then we're gonna have like peoples, okay? Peoples equals to what? The h2 hat and then the hat, okay? So now we have a peoples list here, and which means that for the current uh, so for those which means those peoples are the peoples can wear the current hat, but not all those peoples can be our candidates because we currently we remember we're only going to choose the peoples that currently do not have a hat. Okay, so how do we do that, right? And then, like I said, we can simply use the mask here, right, to represent that. Basically, if sorry, for the people, okay, in the peoples, okay, for people in peoples, right, and then if the mask and is equal to 0, okay, then we know, okay, so that person does not have a mask, okay, dp and then n plus 1, okay, sorry, uh, h plus 1, and then the hat will be mask, uh, do a bit or here, okay, 1, right, so that's that. I mean, for those people, if you still don't understand this part here, basically what this one does is like, you know, since we have a like a few bit to represent each of the persons, right? Let's say, for example, we have 7 persons in total because the okay, so in case we have a 7 persons here, I mean, how can we know basically if this bit value is 1, then we know it represents, okay, this person has the has a has a hat. Okay, then how can we know if this person has a hat or not? We simply do we use the index the number of the person the peoples here, okay, to represent the we have a persons here. That's the ID of the person, okay, and then we just create like a mask here to a 10000, okay, because after this one here, right? I mean, for everything else is 0, which means the only number left, since we're doing a bit end here, the only thing left is this one here. So if if the current mask that has a value 0 at this like value here, at this bit here, then the total number will gonna be 0 because this one is also 0. But if this one has a 1 here, then the total number is not 0. Okay, cool. So that's that. Okay, so I mean, if it's 0 here, it means that okay, so this person can wear the current hat, which means okay, we're gonna use that one as a candidate here. That's why we're gonna update this mask here. Okay, we're gonna update this mask by setting this bit value to 1 by doing a bit or here. Okay, similar like this one. Actually, still here, actually we're using like it's kind of like a little bit like a backtracking here because actually, so what we are doing here, we have to do a bit mask equals to this. Actually, it's equal to this one. Uh, uh, okay, right. So, and then here we're doing a mask here, okay. But then later on, right, since we have a for loop here, it's like a backtracking concept here. I mean, so how do we revert to the mask here, right? We have to this one here. So for those who still don't know quite understand this part, I mean, this is like the bit or here. This is like a bit XOR, right? So the difference is like this. Let's say we have a 0, 0, 1, 0, 0, and 0, 1, 0, 0, 0. Okay. So after this bit or here, the mask becomes what? Becomes to 0, 1, 1, 0, 0. Okay. And for the bit XOR here, for the bit XOR, anything that has the same value will become to 0, and anything that does not have a different value will become to 1. So basically, to revert this 0, 1, 1, 1, 0, 1, 1, 0, 0 back to this original state, we need to do a bit XOR with this value again, basically 1, 0, 0, 0, 0. Okay, so with this part, if we do a XOR here, anything that has the same value will become to 0, 0. Anything that have different values will become to 1, 0, 0. Okay, so that's why exactly the same as this one. That's how we revert this XOR. Sorry, that's how we revert the OR back to its original value by doing like the XOR on top of it. I mean, I'm just trying to explain that here, right? I mean, like I said, you don't have to do it here, but you can just actually by just doing like an OR inside of this DB here, so that you don't have to modify the mask here, okay? Right, like what we did before. Okay, I'm just going to leave it here. So yeah, I mean, so that's the basic like structure here. But okay, now how about the base case, right? With a top-down DP, you always need a base case. So the base case is this, like basically, so when do we need to return, right? So what the base case is like this. Basically, if the mask is equal to the one, uh, okay, I think we also need the n here. Okay, so let me do this. N equals to the uh, n is like the basically the number of person. Okay, that's going to be the length of the hats here. Okay, so when should we stop? Okay, so we stop when every person has a hat. Okay, so when does every person has a hat? It means that let's say we have 7 person. Let's say we have 7 persons, and so each one has like a hat means that we're gonna have like 7 1 here. Okay, that's 7 1s. Okay, and we return when the mask equals to this. So what's this value here? It's this value, right? It's n do the bit move by n times, and then we do a -1. Okay, so that's the base case. Okay, right? So that's our that's our base case, and I think this is pretty obvious, right? So let's say if the n is what? If the n is like 7, so if n is 7, so this thing here, what's the value of that? That's 2 to the power of 7, right? And then -1. That's exactly the value of this one. Okay. So that's the base case, but there we need a one more base case here, and which is, so why is that? Because it could also be possible because as you guys can see, we are keep going over, we keep adding the hats here, right? So there's another like boundaries here, which is the hats. Basically, if the hat is greater than 40, okay, then it means that okay, it, there we don't have hats anymore. We simply return 0 here, which means that this is like a invalid case. An invalid scenario because we have no more hats here. We simply return 0. We return 0 because we are getting the total numbers of ways that each person has wear hats. In this case, it's an invalid person, which means not all the person is wearing hats because we have already checked this case here. So here it means that, okay, at this moment, some people still doesn't have a hat, right? But now we are running out of the hats here. So which means it's an invalid case. Invalid case means that 0, okay? And the base case is here, it means that 1. It means that, okay, we find one way of assigning different hats to all n peoples here. Okay, I think that should do it. Okay. Cool. So this one works. Let's try to submit it. Oops. Oh, sorry. Yeah. We need to do a mod here. Okay, 10 to the power of 9 plus 7. Okay, since the number is huge, we need to do a mod by this here, by this number here. Cool. So it passed. That's basically that's the idea of this one. I mean the time complexity, right? So what's the time complexity, right? So I mean, as you guys can see, so the for the top down, right? So the time complexity equals to the number of the combinations plus the time for each of the combination, right? How many combinations we have? We have an H here, so it's going to be a total in 40. That's the hats times what? Times 2 to the power of 10, right? Because for each of the mask here, right, we have up to 2 to the power of 10 cases. And for each of the scenario here, we have a while here. We have a while loop here, which means we're gonna loop through the person. We're gonna loop through the persons, basically the persons for this hat. So the worst case scenario is that every time we're gonna loop through all the persons, which is like the 10. Okay. Yeah, so that's the worst case scenario for the time complexity, right? And the space complexity is the combination of the memory, right? So the space complexity is this n to the I mean 10 to the 10 times 2 to the power to the 10. Okay, cool. So that's that. Now, how about, since we have been doing like this kind of like top down for a while, how about we try bottom up next? I mean, the bottom, for this kind of problem, the top down is I think it's more intuitive to follow because it basically is follow what the problem is asking us to do, right? It's asking us to assign a hat to a person, right? That's what we are that's exactly what we're doing here. We're trying to assign each hat to a person. By the end we have assigned each person a hat, then we are done. Okay. So that's basically the top-down scenario. And how about the bottom-up? Okay, so for the bottom-up, it's time for us to think it in a reversely, in a in the opposite direction. Basically, we need to think like this, right? I mean, for those basically at the current state, I mean, the state is the same, right? The current state, how can we reach the current state from the previously state, right? Because in the top-down, we're at the current state, we're trying to move to the next state. But here, we're at the current state, but we are trying to think, okay, we're trying to refer to the previously state here. Okay, cool. So let's try to do the bottom up real quick, since this video has already it's already almost 30 minutes. I'll try to do it pretty quick here. So for the bottom up, for the bottom up, what we need to do is I'm gonna come out this part here. Okay, since we'll be still needing this part here. So with the bottom up, right? With the bottom up, we first we need to define like the DP here. Okay, so for the DP here, you know, so for the DP just represents all the states of the top down. So how many states we have here? We have a H times, like I said, we have a 40 times 2 to the power of 10 persons. Okay, in this case, right? In this case, we have like nth persons here, so which means the total state will be uh let's say we have a nth person, right? We have nth person, so the total mask for that is gonna be the what? I'm gonna have like the masks. Uh, what value I should use. Let me try to use the m here. So the total, basically the total case for this m here is like one moved, do a bit move by n times, right? That's why we have a m here for this thing in range like what? 41, okay? Because we have 40 hats in total. And how about this one here? So why it's like m, right? Because we have like, from 0 to 1111, right? So that's exactly the number of this one, plus 0, okay? This is like what? 2 to the power of 4, which is 16, right? That's 6, uh, yeah, that's 16, yeah. Because here we have a 15 here and plus 0, right? Plus 0 here, there's like total 16 combinations here. Okay. Okay, so now we have the DP here, and then the okay, actually I also need this mod here. Okay, I'm gonna put it here. So for the bottom up, right? I mean, the first one is it's a hat, right? So basically, for loop through the hats in range 1 to 41. Okay, so why is that? Because the hat is from 1 to 40, which means that it's 1 to 40. Okay, for each of the 10 to 1 to 40 hats, we also need to loop through the mask here, right? The mask from what? From range of the in range m. Okay, because that's the total possible mask here, right? For each of the m here, right? Because it's from 1 to this number here. And same thing here, right? I mean, so the DP, so the first scenario is going to be we don't take the current mask. Sorry, we don't take the current hat. So which means the current hats uh, will be the same as the current hat, and the mask will be will coming from the same DP H minus 1 mask. Yeah. So which means like whatever how many options we have here, right? How many options we have here to have this many persons, like which the mask is representing from the previously had states, is how many like the weights it will be the same as the current one, because we're not taking the current hat, right? Which means the mask didn't change. Okay. Now uh now for the persons, now the second one is we're taking the current hat. So if we are taking the current hat, okay, so what does it mean? Uh, it means that, I mean, like I said, so what other peoples that can take the current hat? So that's the in hat to persons like hats, right? So here we're looping through the persons that can take the current hat. Okay, so it means that let's say we have a 0, 1, 2, 3. Uh, Basically here we need to think it in a backward way. It means that for the current hat, if the person P is taking the current hat, it means that the previously H minus 1 state, the mask cannot have this person assigned to a hat. Okay, so it means that if in this case, if the person 4 is assigned, the person here, person 4 is assigned this one, assigned to a hat. Okay, So this one means that hat is like maybe hat is 3 here. So it's DP hat 3, person 4 here. So assuming this person 4 is assigned to a hat in the in this case here, so it means that the DP are like 2 here, right? Because we are like because if 3 minus 1, in that case the mask cannot have this person 4 has like a hat because the person cannot be assigned to two hats. Okay, so in this case we have to check, right? Uh, let's see. So first we have to check if the current person has the hat or not. Okay, with the current mask here. Okay, so if the mask and this one here, right? Is 0. Okay, so let me see how can I explain this. So basically what we're checking here is that, like I said, before assigning this person with a hat, okay, if that person didn't have like a hat, then this scenario is valid. Okay, so the way we're doing it, like we're using a current mask to end with this persons, right? And if this thing is not equal to 0, okay. So what does the equals to 0 means? That is the let's see. Let's say the current one is this, like 0, 0, 1, 1, 0, 0. Okay. Let's say we're at this position here. Okay. It means that the current mask, right? The current state is have this one uh, set to 1. Okay. So it means that before the before the current mask here, this value has to be 0. Okay. It has to be from 0 to this value. Then it's a valid scenario because before it doesn't have this. So this person didn't have like hat, but now this person has a hat. But how can we know if this value was 0 or like now it's 1, but before it's 0, it's uh, we just need to check. Basically, we just need to check if the current this value is 1. Okay. The way we're doing it, sorry, I know it's a bit confusing. We're just like doing an AND with this one, like with this bit mask, which is 1, 0, 0, 0. Okay. If the value it's not 0, it means that okay. So currently we have this person has a hat. Okay. So if the person has a hat, now we just need to convert this one back to convert this person's value from 1 to 0 so that we can go back to the previously state. Okay. And if you guys remember, like earlier, I said, how can we revert these things back to its previously state, right? We do this, right? So the basic dph mask uh, dp h minus 1, and then what was the mask do a XOR, right, with this to p. Okay, so that's how we revert these things back. Basically, we reverse this bit value from 1 to 0. That's basically, and which is the previously state at the h minus 1 state. Okay, and then in the end, we simply return, right, the dp what with 40, right, with everything with 40, and then the m minus 1. and we do a mod by mod. So why do we do a -1 here? Because, uh, basically it's the last state, right? We are like creating the m state, the m numbers here, and then we have this -1 as the last element. Uh, cool, but I think we're missing one step here, the base case. As you guys can see here, we're always inherit here. We always inherit here. We never do a +1 in any of the formula here, right? So which means that in the end, everything will be 0. Okay. If you scroll up a little bit here, so in the top-down scenario, we have a base case, which is 1. That's how we can accumulate this number, like from the base case to the final answer here. So which means we also need a base case for the bottom up DP here. So what's going to be the base case? The base case is going to be 0, 0 equals to 1. So this means that, with no hats and no person, there's still one way to assign. Basically, there's one way to assign 0 person with 0 hats. Okay, and that's it. Let's try to run the code here. All right, submit. Cool. As you guys can see, this one, the bottom up is faster than top down because the top down, it needs some additional time to reserve the state of the recursive call here. So that's why the bottom up is faster. But I I agree, it's more difficult to understand, especially for this part, right? I mean, the bitwise manipulation is already hard enough, but with this kind of like backwards thinking, it's even more difficult. Okay, cool. And for this one, it's time and space complexity. Is exactly the same as the top down solution here. And cool, I think that's pretty much I want to talk about, or I can talk about for this problem. Yeah, thank you so much for watching this video, guys. I hope you guys learned something. Stay tuned. See you guys soon. Bye bye.